You look at how your parents did in school and have a thought you were not supposed to have. What if they actually had the better deal? That sounds backwards. They grew up earlier, with less technology, less information, and less of everything that was supposed to make a mind stronger. You grew up later. You were supposed to be the upgrade, and for a long time, the numbers seemed to agree. Across much of the 20th century, measured IQ scores rose so steadily that the pattern got a name: the Flynn effect. James Flynn documented gains of roughly 3 points per decade across many industrialized countries. If history kept moving in that direction, then the generational story felt obvious. Better era, better minds. Your parents were supposed to be one step up from their parents, and you were supposed to be one step up from them. Then, the trend broke. A 2018 analysis of more than 730,000 Norwegian male conscripts found that cognitive test scores peaked with men born around 1975, then declined in later birth cohorts by about 0.2 points per year. And the most unnerving detail was not just the decline, it was that the decline showed up even between brothers in the same family. The United States has its own version of that shock. The National Assessment of Educational Progress long-term trend has tracked 13-year-olds on a comparable scale since the early 1970s. In that record, reading and math scores peaked around 2012. By 2023, reading was down 7 points and math was down 14 compared with a decade earlier. So, no, the comforting story does not survive on its own. Later is not automatically better. And once that falls apart, a bigger possibility opens up. Maybe the rise was never proof that human brains were steadily upgrading. Maybe it was proof that conditions around children had improved for a while and that those conditions can improve, stall, or worsen. The old trend already hinted at that. A meta-analysis of Flynn effect research found that the gains were concentrated in fluid, abstract reasoning tasks, especially tests like Raven's progressive matrices. Vocabulary and general knowledge gains were much smaller. Researchers described that pattern as hollow compared with a clean rise in general intelligence. Even at its peak, the Flynn effect was not one giant arrow pointing up across every kind of thinking. That matters. If the gains were uneven from the start, then a plateau or reversal is not some impossible event. It means the old rise may have depended on very specific things going right. So go back to the early 20th century and look at what was changing around children. One of the biggest changes was iodine. In the United States and Switzerland, iodized salt programs began in the 1920s. In the United States, salt iodization started in 1924. Before programs like that, iodine deficiency was a leading preventable cause of impaired childhood cognitive development. That is easy to say in public health language. In ordinary life, it means something harsher. A child could grow up with a drag on brain development built into the food itself, and nobody in that kitchen would be able to see it. Then, that drag was reduced. Another study used differences in soil iodine across the United States to estimate what happened after iodized salt arrived. For the quarter of the population that had been most iodine deficient before iodization, the intervention was associated with roughly a 15-point rise in average IQ. The authors estimated that this one change could explain around 1 decade of the broader American Flynn effect rise. That is an enormous clue. Part of what people call smarter generations may really be fewer hidden deficits. The gains look less like a mystery inside the skull and more like a repair job outside it. Then there was lead. The United States began phasing out leaded gasoline in 1975 and completed the on-road ban by 1996. Over that same broad period, the share of American children ages 1 to 5 with blood lead levels at or above the era's action threshold fell from nearly 80% in the late 1970s to under 5% by the early 1990s, nearly 80% to under 5%. That is not a tweak. That is a society removing a neurotoxin from childhood at mass scale. Researchers had already shown what lead exposure was doing. In 1979, Herbert Needleman and colleagues studied schoolchildren in Chelsea and Somerville, Massachusetts, and found that children with elevated dentine lead levels scored significantly lower on the Wechsler Intelligence Scale for children. Their teachers also rated them significantly worse on classroom behavior. An 11-year follow-up found that those deficits persisted into young adulthood. So some part of the 20th century rise may have had nothing to do with a civilization mysteriously becoming brighter. It may have come from lifting pressure off developing brains. You can see the same logic in Flint. In 2015, pediatrician Dr. Mona Hanna-Attisha started analyzing local health records after the city's water source switch. What she found was not a vague concern. The share of Flint children under age 5 with elevated blood lead levels had nearly doubled citywide, and in some neighborhoods had nearly tripled after the city began drawing water from the Flint River. Now bring that back down to the level where families live. A child cannot focus. A teacher notices behavior problems. A parent starts worrying about school. Every case arrives one child at a time, so every case looks personal. Then someone lines up the records, and a pattern emerges. What felt like scattered private trouble turns out to be a public health failure. That is what makes this subject so easy to misunderstand. The data show up as points on a chart. The damage shows up as ordinary disappointment. That is the part people miss when they talk about intelligence as if it were a fixed private possession. Scores are taken one person at a time. The forces moving them often are not. Once you see that, the Flynn effect looks less like a ladder and more like a patchwork. Remove one burden here, reduce another there, improve early childhood conditions, and some scores rise fast. But a patchwork can stop growing. It can thin out. In some places, it can reverse. Meta-analytic work found gains of roughly 5 to 6 points per decade on culture-reduced abstract reasoning measures like Raven's progressive matrices, but near 0 to 2 points per decade on vocabulary and general knowledge measures. The later plateau or reversal was uneven too. It has been documented in countries including Norway, Denmark, and Finland, so younger cohorts really are falling behind in some places and on some measures, but the rise before them was never one smooth law of history. Back to the present, look at the phone in your hand. There is evidence here, but it is mixed. Research on screen time, multitasking, and attention-related difficulties in adolescence shows some associations between heavier or faster-paced screen use and attention problems. Other studies find that the effects depend heavily on the kind of content and on individual differences rather than on screen exposure by itself. So, no, you cannot cleanly say your phone made your generation less intelligent. The evidence does not support that shortcut, but the recent declines also cannot be written off as a weird pandemic blip. The PISA 2022 results showed the steepest score drops on record, with the OECD average down about 10 points in reading and about 15 points in mathematics compared with 2018. And the OECD's own analysis said the pandemic explains only part of that decline because reading and science scores in many countries were already falling before 2020. That rules out the laziest answer. COVID made things worse, but it did not invent the whole problem. A score is not just a reading of the person taking the test, it is also a reading of the conditions around that person. A 2001 model proposed by Dickens and Flynn argued that high heritability within a generation can still coexist with large environmental changes across generations. In other words, people can differ partly for inherited reasons inside the same world, while the average for the whole population still moves quickly when the world itself changes. Heritable does not mean permanent. The Norwegian brother comparison makes that real. If later-born brothers in the same family score lower than earlier-born brothers, there is no new gene pool to explain the variation. The family's genes did not meaningfully change in a few years. Only the conditions did. Your comparison with your parents is not a clean contest between one brain and another. It is a comparison between two developmental environments, two school systems, two public health landscapes, and maybe two very different attention climates. James Flynn pushed back on the flattering myth that later generations are simply smarter. As he put it, I prefer to say our brains are more modern, and modern does not always mean better in every direction. If the room gets cleaner, quieter, safer, better fed, and less toxic, scores can rise. If new friction enters the room and old protections weaken, scores can stall or fall. The number on the page is not a verdict from nature. It is a reading taken inside a particular environment. That is why the same society can produce a long rise, an uneven plateau, and a sudden drop without anybody's DNA changing at all. So when that thought lands, the one that says maybe your parents had the better deal, do not hear it as an insult. Hear it as a clue. Change the conditions, and the number changes with them.